Hello guys, today I'm going to introduce you to Sumo. What's Sumo? Sumo is an open source traffic simulation package. The development of Sumo started back in 2001. With Sumo, you can build a network and assign routes within the network. You can develop traffic light algorithm. You can simulate and analyze traffic within a network given origin, destination metrics, etc. and so on. Before going further, let me give you an overview of transportation simulation software. In transportation simulation, we have software like Sun Life, CORSIM, Paramix, vSim, Sim Mobility, Synchro, plus Sim Traffic, MatSim, TrainSims, Sumo, etc. And as you can see, most of them are commercial software. As open source, we have MatSim, TrainSims, Sumo, and other. But among all those open source software, we have Sumo that is more advanced up to now. Maybe in the future that will change, but up to now Sumo is more advanced when it comes to open source transportation simulation software. Before starting, you should download and install Sumo and also Python. Python is necessary for some simulations. In Sumo, a route network can be created in three ways. It can be created manually by creating your own node, edge, route, connection files, and so on. You can also use the net generate command, or you can import a route network from external sources such as OSM, that stands for OpenStreetMap, vSim, vSum, etc. This flash tutorial will be divided into three parts. In part 1, I'm going to show you how to manually create your node, edge, route, and configuration files. In part 2, which will not be covered in this video, it will be covered in the next video, we are going to see how to import a map from OpenStreetMap and build our network and assign a random trip to the network. In part 3, we are going to see how to use origin destination metrics in order to generate trips and simulation. Without further ado, let's get started. The first part, which is manually design node, edge, and route. This is the node we want to build today manually. As you notice, a network is nothing but nodes connected by edges. The edges are the roads that connect the nodes. The nodes are also called the junctions. Each node has a coordinate X and Y, and we are going to use those coordinates in order to build our node. This is the flow chart of the creation of our network. The very first step is to create our node file. and the extension of the node file will be .nod.xml. The second step is to create the h file with the extension .edg.xml. The third step is to create the h-type file. The step 4 will be to create or to generate the network from the node h and type files we previously built. And then next, we are going to build our route file. To build the node file, we just need this set of comments. As you can see here, we have to assign node ID. Node ID, you can call that anything you like. I call that N1. X is the X coordinate, Y is the Y coordinate, and type. In type here you can set many things like the priority, or is the node controlled? Is there any traffic lights at the nodes? All those kind of things you can include in the type. So here we have defined all our nodes with the coordinate and the type. We will call this file mynode.node.xml. You can call that anything you like. Let's open a text editor and copy this and paste into the text editor. Firstly, let's create our workspace. Let's call that Sumo demo. Okay. Let's open Notepad++ and paste our code into it. We need to replace this bent quote by straight quotes. Okay, let's save this file. Let's save that into our folder. Okay, let's move to the next step. Okay, now let's create the h file. As I said before, the h are the links that connect the nodes. This is how to define the edges. We start from a node to another node. From N1 to N2, we have our link, that's one edge. The ID, you can give it anything you like. I just call it 1 to 2 in order to remember easily. And as for the type, you could call that anything you want, A, B, C, X, Y, Z, anything you like. I just call it here 3L45 to mention that I want the first edge to have 3 lanes and have a maximum speed of 45 meters per second. For the second edge, from N2 to N3, I gave the ID 2 to 3 and the type 2L15. That means I want the second edge to have 2 lanes and have a maximum speed of 15 meters per second. And again, as I said, I'm going to define that in the next slide. Those types have to be defined. Likewise, from N3 to N4, the ID, I call that 3 to 4, and the type of lane, 3 lane, and maximum speed 30 meters per second. And lastly, from N4 to N5, I call that ID out in order to say that this is my output. And the type 3 lane with a maximum speed of 30 meters per second. I'm going to copy this code, paste it into Notepad++, and call that file myh.h. myh.h.xml. Let's move on to the next step. We need to create the type file, which has extension .type.xml. The type file includes route priority, the number of lanes, speed limit, type of vehicle allowed, etc. This is one example. As you see here, we just give the type ID, which was defined in the previous slide, remember? So 3L45 means the number of lanes is 3 and the speed is 45 meters per second. So we have to define the type ID explicitly. For the priority option here, the more the number is higher, the more the priority. That means that lane will have higher priority. So here, for example, the age with 3L45 will have priority of 3. That same priority with 2L15, and the 3L30 will have the lowest priority. This is just one example. Let's copy this and paste it into text editor, Notepad++, and save it as mytab.type. Next, the netconvert now is going to assemble the node file and the age file and the type file, and it's going to output the net file, the network file, the actual network file we are looking for. I've called that mynet. You can call that anything you like. And this is the command we are going to use in order to generate the network. So we start with netconvert, and then we give the node files command, then the name of our node file, followed by the command h files, and then the name of our h file, followed by t. This t means type, followed by the name of our type, then o. O means output. It's going to output mynet.net.xml. Let's copy this code. And open a command line. Now let us open a command line that's directly aligned to this directory. The easiest way to do that is just to tap CMD and press enter. Let us copy our command and paste it here. It says error, could not open the node file. Okay, this is because I saved it. It should be my notes instead of my note. Let us run it again. It says successfully. Now you can see that we have our network here. This is the file that has just been generated. We can delete it and run the command line again to see. If we press enter, this mynet.net file that has been created. Let us open it. This is our network that has been created manually. So you can see here that we have the ID types with the priority we set before and the maximum speed. This is what our network look like. If you are not familiar to this, do not worry. With time you are going to understand in details. I was just quickly showing you what it looks like. We have the connection here, we have the junction, we have the edges, the types, so we have everything. But now we didn't create the route yet. We just have the physical network, but without defining the route. Let's continue in our PowerPoint file. Now, to create the route, we just need to copy this code. In this code, you will see that we have the vehicle type, which consists of acceleration, deceleration, the ID of the vehicle, the length, the maximum speed of the vehicle, etc. Here I created a car and a bus. The only differences are the length of the car, the length of the vehicle, and the maximum speed. I just made it just one in order to check if it really works on the network. Later on we can change it. Here we have the route ID. We define the route ID. You can define anything here. And the edges. The edges from 1 to 2. And then it goes to the edge 2 to 3. And so on. So this is how we define our route. And we also define the departure time. Here 10 means 10 seconds. This means at 10 seconds the vehicle with ID route 0 start. And what's the type of this vehicle is bus. So it just come here and take all these characteristics that we have defined here for the ID bus. Likewise, route ID 1 is defined from 2 to 3 and 3 to 4, and so on. Let us copy this and paste into our network and paste into a text editor and call that my route file .rou.xml. Okay. Now that we have the network and the route, the last step is to build the Sumo configuration file. And this is what the configuration file looks like. We have the input that consists of our network with give the name of our network here, the network that we have just created. We call that mynet.net.xml. And the route files, we call that myroute.rou.xml. Those are the inputs for this case. And we also have the time. We set the time. The beginning is 0 seconds and the end time is 2000 seconds. Again, you can change these values. So this is the simulation length. We'll just copy this and paste it into a notepad, into a text editor, and save it as my config file dot sumo config and save it. Let's go into our directory. We notice here that the myconfig file has directly been recognized by Sumo, and as the type file here, we can see here that this is Sumo configuration file and all others are XML files. Let's open the myconfig file now. And voila, we have our network. Now the very first thing we want to check is if the link, the edges, are exactly what we were expecting by checking in the, so as shows the network in the PowerPoint, we have exactly the same structure here. The second thing we want to check is the number of lanes. Before, what we designed here, we said from node 1 to node 2 is 3 lanes. From node 2 to node 3 is 2 lanes. And the remaining are 3 lanes. So 3, 2, 3, 3. Let's check it. Yes, these are our 3 lanes. 1, 2, 3. We can use this tool in order to check the lane labels. And here we have our 2 lanes, 3 lanes, 3 lanes. So everything's okay up to now. Let's run the simulation and check. Let's first increase this delay in order to easily see the simulation. So we have increased the delay to 100 milliseconds, meaning 0.1 second. So that means the simulation steps will be 0.1 second. Let's run the simulation step by step. And remember, what we defined was vehicle 0 will start at 10 seconds. And it's going to choose, and it's going to travel through the route 0. And the route 0 is what? Is the edges from 1 to 2 and 2 to 3. And what's the vehicle 0 type, the type is a bus. So that means at the first link we are going to have a bus, and that bus has a maximum speed of 1 meter per second, and its length is 12 meters. The acceleration, the maximum acceleration is 1, and the maximum deceleration is 5. The vehicle 1 is going to start also at 10 seconds, and it's going to go through the route 1. What's the type of vehicle 1? The type is a car. And what's the route? Route 1 is ages 2 to 3 and then 3 to 4. Likewise, vehicle 2 is going to go through the route 2. The route 2 is from 3 to 4 to the output. And what time is it going to start? It's going to start at 30 seconds, and the type is a car. Let's go into the simulation, into Sumo, and check it. So we are expecting to see the first vehicle at 10 seconds time. You see, this is 10 seconds. This is our bus that shows up here, and here also we have our first car in this node. In node 1 we have the bus, in node 2 we have our car. Let's see that in real world mode. Let's zoom. Okay. And what was the maximum speed of each vehicle? Let's check it again. The maximum speed of the bus is 1 meter per second, while the maximum speed of the car is 100 meters per second. And remember, the distance between node 1 to node 2 is 250 meters. What does that mean? It means the bus that starts at node 1 is going to reach node 2 at what time? The speed of the bus is 1 meter per second. And from node 1 to node 2, it's 250 meters. So that means the bus is going to take 250 seconds to reach node 2. So we are going also to check those things to see if Sumo is really working. Those are the basic things we should sometimes check. Let's go through it quickly. Yes, notice that. And yes, at 250 seconds exactly, the bus was there. So you can also play with this. You can change many parameters and play in order to understand what's going on. Also notice that the bus is going to disappear at node 3. Yes, it disappears from the simulation because we have specified the route of the bus. We specified that it's going to go from edge 1 to 2 and then from node 2 to 3. That's it. So what if we wanted the bus to run throughout all the network? We need to check what was the ID of the last edge. In order to know that, we need to go in the edge file. This is the edge file. And the ID of the last node, the ID of the last edge was called out. So out was that ID. So if we want our bus to go through all the network, maybe we will be tempted to just put out here instead of 2, 3. But let's run this. Let's go into the command line and again call the net convert in order to create our network. Let's see what's going to happen. Yes, here it says success. That means the new network has been created. Let's run again the code here in Sumo. Let's restart it. Sumo is complaining that vehicle 0 has no valid route, no connection between edge 1 to 2 and edge out. This is because from the first edge to the last edge, we need to specify all the intermediate edge in order to show the route to the bus. So if we wanted the bus to go throughout the network, then we would like to specify from 1 to 2 and then 2 to 3 and then 3 to 4 and then out. So we give all the intermediate route in order to show the way, not just the beginning and the end of the edges, no, but also intermediate edges. Let's save this. Let's build again our network. Let's go again into Sumo. Okay, I forgot to mention something, that we can also run Sumo from the command line using this command. Let's copy this and paste it in the command line. Ctrl V. Yes, and it opens Sumo. Now we want to check if the bus now goes through all the network. Let's run it. Let's decrease the delay for it to go faster. Now we can observe that the bus goes through all the network. So that means we have to specify all the route, not just the beginning and the end. So I advise you to play with all the parameters in order to get acquainted with all the files. That's pretty it for this first part of the tutorial. So the next part, the next video will be about how to download an actual map from OpenStreetMap and then convert that map into a Sumo network and assign a random trip into the network. And part 3 will deal with origin destination metrics. So please subscribe for more to come. Thank you for watching. Bye.